When we talk about a strong acid and a strong basis, we in fact talk about the ionization constants or equilibrium constants of the acids and the bases. If Ka for an acid is much greater than 1, we call it strong acid. If Ka of an acid is much less than 1, it's called weak acid. For a base, if the base has a very large Kb, then it's called strong base. If Kb is much less than 1, it's called weak base. From the expression of Ka and Kb, we see that large Ka and Kb mean the very large concentration of proton or OH minus. Here in the table, most common strong acids are listed. Hydroiodic acid has the very high ionization constant of 10 to 9 or 11, very strong acid. Nitric acid has a value of 20, tend to ionize in water to a large extent, a strong acid. Because these acids have so large ionization constants, it's believed that all the strong acids are 100% ionized in water. Sulfuric acid donates protons in 2 steps. In the first step, it ionizes completely to give proton and hydrosulfate ion with Ka1 greater than 100. The hydrosulfate ion continues to ionize in the second step, generates proton and sulfate ions. The ionization constant for the second step is 1.1 times 10 to minus 2, much less than 1. So hydrosulfate ion is a weak acid, while sulfuric acid is a strong acid. Here shows the common strong bases. Most hydroxides of group 1 and group 2 elements are strong bases. There are also some salts with H-, O2-, and S2- ions are strong bases too. Some hydroxides are completely soluble. For example, sodium hydroxide dissolves in water completely and ionized completely. Some hydroxides of group 2 elements show limited solubility in water, but the dissolved hydroxides ionized completely, so they are still strong bases. These hydroxides generate OH- ions directly in water, while the ions shown in the table, these ions act as strong bases because they react with water. See the slide. The reaction goes to 100% completion, so the salts with these ions are strong bases, such as sodium hydride, sodium oxide, sodium sulfide.